In this session, we're going to solve the tutorial sheet on exponentials and logarithmic functions. So we are going to solve all these questions. So from question 1 to 6, all of them, we're going to solve them. Then we're also going to solve from 8 to 10. And there are any other questions? Yes, until to 13. So we're solving tutorial sheet 6. So we're going to solve all of them. So without wasting much of the time, so let's start with the first question. So question number 1, we are saying given the exponential function f of x is equals to 1 over 4 to the power x, evaluate each of the following. So this question 1 is on exponentials. So let's start with a. We are being told that it is f of negative 3. So what this means is that in the function where there is x, will be replacing negative 3. So we are, the first question is the function itself is 1 over 4. Then we are saying x should be negative 3. So we're going just to do that. Then you know that the negative 3 falls on 1 and on 4. What I mean is that this negative 3, it will be to the power, it will go as a power on 1, it will also go as a power on 4. So let's just do that. So I'm going to have 1 to the power negative 3 on top, divided by, on the denominator I'm going to have 4 to the power negative 3. Now 1 to the power negative 3, it's just the same as 1 over 1 to the power 3. Then when I come down, 4 to the power negative 3 is just the same as 1 over 4 to the power 3 according to our rules of exponentials. So when I solve on top, 1 divided by 1 to the power 3, it's just going to give me a 1 on top, over 1, I'm going to write my 1 divided by 4 to the power 3. 4 times 4, that is like 16. 16 times 3, 16 times 4, that is like a 64. Now I have a scenario where I have 1 divided by 1 over 64. You know that, you know, your sign changes, you're going to have 1 times 64, right? So our final answer for this one to just be what? A 64. Okay, so let's solve B. Now B, we are saying f of, you know, negative 1 over 2. Okay, so our function f of x is 1 over 4 to the power x. So now if you are saying f of negative 1 over 2, we're just going to replace where there is x. Actually there is x here, so we have 1 over 4, then to the power negative 1 over 2. So what are we going to have? This you know, power is going to fall on 1 and on 4. Now when it falls on 1 to the power anything, it's going to give you a 1 still. Okay, so let me just say this is just a 1 on top, over then 4 to the power negative half. Okay, so I'm going to have a 1 over, now 4 to the power half, you know that's just the same as 1, the negative becomes a 1 over 4 to the power half itself. Okay, now when I simplify this, 1 on top remains. Now I have my 1 over, now 4 to the power half is just the same as the square root of 4, right? And the square root of 4 is just a 2. So I have a scenario where I have a 1 divided by 1 over the square root of 4, we said it is a 2. So I'm going to have a 2 here. Now 1 divided by half is just the same as 1 times a 2. Okay, the denominator and the numerator swap like that and just have a 2. So for our second question, our final answer is a 2. So this is equals to a 2. Now let's solve the last one. Is it, let's solve C. Okay, there's not much to solve on C because we are saying f of x is equals to, now where there is x, we're replacing by 0, we're putting a 0, f of 0. So any number to the power 0, it's going to be a 1. Okay, so this is just a 1 according to our rules of exponentials. So if you are new to this channel, you can also check the videos on exponentials and logarithmics. Okay, so now let's solve D. We are saying f of 4. Okay, so where there is x, we are replacing 4, and our function is f of x is equals to 1 over 4 to the power x. Then we're saying f of 4, our f of 4 will be 1 over 4 to the power 4. Now the 4 is going to fall on 1 and the 4 is going to fall on 4 itself. So 1 to the power 4 is just a 1. Okay, then 4 to the power 4, what are we going to have? I'm getting a 256. So 1 over 256. Okay, so that is my final answer. So this is how you solve the first question. Now let's solve the second question. Now I'm taught to sketch the graph of the following. Okay, now this is a very interesting topic when it comes to graphing. Okay, maybe let me not write it. Let me write it like this. If that is our graph, okay, and let's say this is our y-axis, this is our x-axis. Okay, now we're taught to sketch the graph of each of the following. So now for exponentials, what you should understand is that you have the x-axis as the asymptote. Okay, we're going to call it the horizontal asymptote. Then for the logarithmic functions, it's a bit different. It's the opposite actually. It's going to be the vertical asymptote. Okay, so what are we talking about? An asymptote is that point on a graph that you are not supposed to touch. So like we're saying for exponentials, you have a horizontal asymptote. So what it means is that the x-axis, you're not supposed to touch this x-axis. If you're just solving a basic exponential function, so it means your graphs are either going to be in this region or in that region, never touching the middle part. Okay, then on the other hand, for logarithmic functions, the vertical asymptote, the y-axis, you're not supposed to touch this unless if there's a shift. Okay, so your graphs are going to fall in these regions like that. So that's the difference. Now we're going to solve those questions. So let's solve those questions. Let's solve these questions based on the information that we just talked about. So we have f of x is equals to 3 to the power x. Okay, so let's look at the value of x. Let's also look at the value of y. The value of y here, we're talking about the value of the function itself. So look at the power x as a power here. It is positive, so we're going to the positive values of x. Then look at the value of the whole function. The value of the whole function is positive, so because it is positive, we're also going to the positive values of y. So what are we going to have? It means our graph is going to come from this side. It is going to go like that, going to the positive values of x and the positive values of y. Now it's going to cut this point, so we have to find this point, and that point is what we call the the y-intercept, the point at which you cut the y-axis. Now we have f of x is equals to 3 to the power x. Now we're saying on the y-axis, the value of x throughout is 0. So if you're going to replace 3, then if you put where there is x, you put 0. We're just going to have 3 to the power 0. We've said any number to the power 0 is just a 1. So therefore this point, it is 0, 1, and that is your graph like that. Very basic, not complicated. Okay, so that's how we solve the first one. Now let's solve g of x. Okay, so the same principle. Let's look at the value of x and let's look at the value of y in the equation. Okay, now look at the value of x. The value of x, you're able to see that it is positive, so we're going to the positive values of x. Then look at the value of the whole function. The value of the whole function, it is also positive. It is also positive, so we're going to the positive values of y. Okay, so now how are we going to go? We also have to find where our graph is either going to cut the x or the y axis. We've been given a shift of -4. Okay, so initially our asymptote, we said the vertical asymptote or the horizontal asymptote is this one, is y is equals to 0. But now we've shifted our graph 4 units down. Okay, so meaning our vertical asymptote is going to shift 4 units down. So let's just indicate that on our graph. So let's say this is now -4. Let me say this is -4. If that is -4, and let's assume this is the line for -4. Okay, so therefore our graph can go this way. It can go like that, in that direction. Now that's not a straight line, but it's just a graph like that. It can also pass through this middle point, going like that as well. It can also move in this direction, going like that. So now which of these scenarios is correct? So we have to find where it is cutting the y axis. Okay, so how are we going to find where it's cutting the y axis? So not a complicated concept. So we are saying g of x is equals to 3 to the power x minus 4. Okay, now where it is cutting the y axis, you know that is the y intercept, right? And then on the y intercept, x is equals to what? A 0. Okay, so we are saying g of x will just be equals to, or if you say just y, so 3 to the power on the y intercept, x is equals to 0. So let me put a 0 here, is equals to -4. 3 to the power 0, that is just a 1, minus a 4. 1 minus 4, that is just a -3. So the value, so this is going to cut the graph at -3. Let me say this is our -3. Therefore our graph is going to pass like that and go in that direction. Now it's going in that direction. Now it has cut also the x-axis at this point. So we're supposed to find the value of that point. Okay, so we are saying g of x is equals to 3 to the power x minus 4. So what are we going to do? On the x-axis, the value of y is what? Is 0. So we're just going to replace sequentially. So here we're just going to say 0 is equals to 3x minus 4. So for me to get x, I'm going to take the -4 to the other side, it will be positive. So our 4 is equals to 3 to the power x. Now for my x to drop, I'm going to introduce natural log. Okay, so if I introduce natural log, this side of natural log of 4 is equals to natural log of 3 to the power x. Now from your rule of logarithmic functions, if I've got a log, let me say log of let me say 3 to the power, let me say 5 or 4, and let's say the base maybe is 10, or okay, if I haven't put the log, if I haven't put the base, just always assume that it is 10, a common log. This is a natural log. It has a base of e. That's why they haven't indicated, but it has a base of e. Okay, so what this now means is that the 4 is going to drop. Okay, so I'm going to have 4 log 3. That's according to the rules of logs. So even this, that's what we're going to do to our expression. So we're going to have natural log of 4 is equals to, the x is going to drop. I'm going to have x natural log of 3. Natural log of 3, I'm going to divide it on both sides. So therefore my x is equals to natural log of 4 over natural log of 3. So this you can leave it here provided you're not allowed to use a calculator. So natural log of 4 over natural log of 3. Now when I punch that on my calculator, what I'm getting, it is a 1.26186, the same point, okay, when I punch that on a calculator. So that's how you're going to solve this one. Okay, so let's also solve the last one. So how are we going to solve the last one? Same principle, same concept. So if we say this is our y-axis, this is our x-axis, okay, like that. So we're saying h of x. So how are we going to solve h of x? So we also look at the value of the function. Let's look at the value of x and the value of y. So the value of x here, you're able to see that x is positive, so we're going to the positive values of x. Then look at the value of the function, the whole function, you're able to see that it's also positive. So we're going to the positive values of x and the positive values of y. So now what do we now do? So we have to also find, because you're able to see that this one is going in this direction. Since it's going in that direction, it's going to cut the graph at this point, and that is the y-intercept. On the y-intercept, x is equals to 0. So we're going to write h of x is equals to 2x minus 3. So therefore h of x, to find us that point, we're going to say 2. Since every x value on this y-intercept is 0, we're going to say 0 minus 3. Therefore I'm going to have 2 to the power, let's say this is 0 minus 3, that is just a negative 3. So I've got 2 to the power negative 3, and you know that 2 to the power negative 3, according to exponentials, the negative becomes a 1 over, it's going to be 2 to the power 3. Now 2 to the power 3, so I'm going to have 1 over 2 to the power 3, you know that that is just 8. 1 divided by 8, that is 0.8 into 10, that is a 1. Remember 2, 8 into 2, 8 into like 20, that is a 2. Remember 4, 8 into 40, that is like a 5. Okay, so this point is 0.125, comma 0 if you want. Okay, so that is how you solve question number 2. Now let's solve question number 3. Okay, so we are solving now question number 3. So we are told to sketch the graph of each of the following functions. So a, we're saying f of x is equals to 1 over that. Okay, so it is the same principle. Let me just draw my we're going to use one graph just to explain this concept. So let's say this is our y-axis, this is our x-axis. Okay, so y, x. So for a, it's the same principle. We have to look at the value of the function itself and x. So x is equals to y is equals to. So for x, you're able to see that x here, you're going to the positive values of, actually it's not the positive, it will be the negative. Why is it going to be the negative? Because negative half, we are saying f of x is equals to 1 over 2 to the power x. Negative half is just the same as 2 to the power negative x, right? So because the values of x are negative, you're going to the negative values of x. Then what about the value of y? You're going to the positive values of y, because the whole function itself, it is positive. Okay, so we're going to the positive values of y. So in which direction? We don't have any shift anywhere, so we're going in this direction. So we are going in that direction, and we have to find this point where it's cutting the y-axis. So to find that point, you know that on the y-axis x is equals to 0. So if I put a 0 here where there is x, any number to the power 0 is just a 1. So this is 1 comma 0. So that is that point. So that's how you're going to solve the first question. What about our g of x? Question B. So for our g of x, same principle. Let's look at the value of x. Let's look at the value of y. The value of x, you're able to see that it is positive. It is also negative in this case. It is also negative because we have 1 over 3. We are saying g of x is equals to 1 over 3. 1 over 3 is just the same as 3 to the power negative 1, right? Then we have an x. So plus a 2. So the value of x is negative. So we are going to the negative values of x, but we are going to the positive values of y because the whole function you're able to see that it is positive. So because it is positive, where is x positive and where is y, negative? So that's what we are going to do. And what do we now have? So it means our graph, it is going to come, but now we have a shift of 2. Okay, so we have to also have to consider that initially our graph should be, our horizontal asymptote should be on 0, on y is equals to 0. This should be our horizontal asymptote, but now we shifted it 2 units on top. Okay, so it means, let's say our 2 is here, so it means now our graph is going to be, this will be like a demarcation. Okay, we are not supposed to cross that line. So it means our graph is going to come from this side. It's going to be going in that direction, but it's never going to touch this point. This point, the line 2. But now we've cut the graph at this point. Okay, because we're going to the negative values of x. So this one is going like that, but we're going to also the positive values of y. So what are we now going to have? What we're going to have now, where we're cutting the y-axis, that is the x-intercept. On the x-intercept, x is equals to 0. Now if I put a 0 here, I'm just going to have 1 plus 2. 1 plus 2, that is just a 3. So this point there, it is a 3. So this is how you are going to graph this one. What about C? Now C, we're told h of x is equals to negative 1 over, that is 1 over 3. Okay, so we're saying h of x is equals to 1 over 3, that is just the same as 3 to the power negative 1, right? Then this is multiplying by x plus 4, like that. So how are we going to solve this one? So now you're able to see that the value of x itself is negative, the value of the whole function, it is positive. Okay, but do we have a shift? No. Okay, so how are we going to move? So it's going to move, yeah, in like just the way the previous one was. So that's going to move in this direction, and it's going like that. Since we don't have any shift, it's going to be going in that direction. Now we've cut this, the y-axis at that point, so x will be 0 at that point. So you're going to have h of x is equals to 1 over 3. Since x is 0, so I have 1 over 3, 0 plus 4. 0 plus 4, that is just a 4. Okay, so I'm going to have 1 over 3 to the power 4. That will be equals to 1 over 3 to the power 4. 3 times 3, that is like 3 times 3, that is like 9. Okay, so that will just be like is it 81? So 1 divided by like 81. So this will be this point. When you divide, you're going to find that point. Okay, so that's how you are going to solve this one. But when I do it on a calculator, I'm finding this point as 0.01235, and it's going like that. So that will be that point if we're going to solve it like that. So that's how we're going to solve our C. Okay, now sketch the graph of each of the following. Okay, so sketch the graph of each of the following. So sketching exponential functions, the concept is not very much different. Okay, not very much different. Now what has just changed is that we now are solving logarithmic functions. How do we solve the natural log? How do we solve the common log? Okay, so that is the principle. Then earlier when we started, I said for the logarithmic functions it is different. You are going to be using the vertical asymptote. You're going to be using the y-axis as the vertical asymptote. Means you're not supposed to touch that graph. Okay, so that is the difference. So let's start with the first one. So A, we are saying f of x is equals to e to the power negative x. Now we have to also use the same principle, the value of x and the value of the whole function. Now you're able to see that the value of x, it is negative. We are going to the negative values of x. Then what about the values of y? The value of y, f of x, okay, the value of the whole function is positive. Okay, so what do we now do? Now if we replace let's say how is our graph going to go? So sketch the graph of each of the following functions. F of x equals to a, okay, e to the power negative x. So we have x going to the positive negative x, so negative x is in that direction and positive y. Okay, so here x is positive, y is negative. Now x is the opposite, actually x is negative. Okay, so that's the direction in which we are going. So it is going to go in this direction. Okay, so it will be going in that direction. Since it's going in that direction, it's cutting the graph at that point, and when x is equals to 0, so it's going to cut the graph at that point only in a special circumstance. Okay, so it's going to cut the graph in that regard. And this point, if we put on the y-axis x is equals to 0, if we put a 0 here, it will just give us any number to the power 0 is just 1, right? So this would be 0, 1. So this is 1 there, and that's how we're going to graph this one. Now let's graph the second one. So we are saying g of x is equals to negative 2 plus e to the power x minus 1. Okay, so what are we going to do? So we have a shift of negative 2, so we have to shift 2 units down. Okay, so we have to shift 2 units down. So if we say 2 units down, which one? So let's say our negative 2 is here, so we're going to consider this point. Since we're considering that point, what do we now have? We have the value of x and the value of y. The value of x, we're able to see that x in this case is positive, so we're going to the positive values of x. The value of the whole function, it is also positive. Okay, so we're going to the positive values of y. Likewise, we have to now consider our graph can go in this direction. It can pass through 0, 0, the middle point, or it can also go in that direction. Now which one of these ones should we consider? So for you to find that, you have to find the y-intercept. On the y-intercept, x is equals to 0, so f of x will be equals to negative 2 plus e to the power x we're saying is 0, so 0 minus 1, that is just a negative 1. Okay, so we have like negative 2 plus you know that e to the power negative 1 is just 1 over negative, the 1 over e. Now e is like 2.7. okay, e is like 2.7. that's Euler's number. So Euler's number, so if we're going to say negative 2 plus 1 over, let me say 2.7, this will give us a 0 point something, and that's 0 point something minus 2. We're going to get a negative number here, and when I just do that on the calculator, I'm getting negative 0 point negative 1. Actually, what am I writing? I'm getting so if it's going to pass, so it's going to pass through this point like that. So this is negative 1.6321, and like that is going. So that is that point. But now we're also cutting the x-axis at this point. So since we're cutting the x-axis at that point, so what are we going to do? So we're using the same principle. On the x-axis, y is equals to 0. So we're saying 0 is equals to negative 2 plus e to the power x minus 1. I take the negative 2 to the other side. I'm going to have 2 is equals to e to the power x minus 1. Then I'm going to introduce natural log. When I introduce natural log on both sides, I'm going to have natural log of 2 is equals to natural log of e, that is just a 1. okay, it's like you've written log in base 2 to 2. This will give you a 1, therefore you're just going to remain with that. Or this, the power is going to drop. When this power drops, then this one will cancel. So what are we going to remain with? We're just going to remain with x minus 1. For me to remain with x on the other side, I'm going to have natural log of 2 plus 1 is equals to x. So this point, it is natural log of 2 plus 1. Now when I punch natural log of 2 plus 1 on my calculator, I'm getting something like 1.69315, and so that is the x value here. okay, so that's how I'm going to solve this one and see like that. okay, now question number 5, convert the following exponential equations into logarithmic functions. okay, so this I'm not going to solve all of them because these are just basic ones. So we are converting, let's start with a. We're converting 6 to the power 3 is equals to 2 to the power 16. Now you know that according to your exponentials, 6 is the base. The general form of an exponential function is f of x is equals to, let's say, 2 to the power x. It is a number raised to a letter, and since it's a number raised to a letter, this is not the same as the opposite. If I say x to the power 2, this is a quadratic or it's a polynomial, but we're not talking about, it's the opposite. So this is the base, so this one is called the base, the 2 is the base, the x is the exponent, or what we call the power. okay, so we are converting from the log, from one log to another, or let me say from the from exponentials or to logarithmic functions. In this case, we're converting from exponential equations into logarithmic functions. So since this 6 is the base, so we're going to write log, the base is 6, okay, according to the definition of an exponent. okay, now what are we going to do now? Since it is equals to this, so we're finding the log of this. okay, so we're finding the log of 216. It will be equals to the power 3. So that's how we're going to do that. For our b, we're saying 4 to the power 5 is equals to 1024. So it's still the same log. 4 is the base, so the log 4 is the base, so it's 4. What are we finding? We're finding this. okay, so we're going to say 1024 is equals to the power is 5. So same with the other ones. That's how we're going to do these ones. Let's solve number 6. Now number 6, we are told to convert the following logarithmic equations into exponential functions. So these are some of the basics. We're saying log of 1 over 7 of 49 is equals to negative 2. So a simple explanation that I can give, if I've got a log of, let me say 2, let me say 5 is equals to, let me say 1. Okay, this is just a generated question. So the way we're going to change to exponentials, get this one as the power and to be equals to that. I'll repeat, you're getting your base to be equals to that, because you know that this is the base. You're raising a number to a letter, okay, and this is the base for the log. It will also be the base for the exponent. Okay, so since this is the base, it's going to be equals to this, and this will be equals to that. So what do I mean? When you simplify it, I'm going to have 2 to the power 1 is equals to 5. Very simple and very straightforward. So even in our case, that's what we're going to do. I'm going to say this 1 over 7 to the power that is equals to that. Yes, to the power negative 2, and negative 2 be equals to 49. So what am I saying? It is 1 over 7. This, it is to the power negative 2 is equals to 49. Okay, so for our b, how are we going to solve our b? Our b is log of 7 343 is equals to 3. So what are we going to do? We are saying 7 to the power 3 to equals to that. So it will be 7 to the power 3 is equals to 343. Now you can try this one. 7 to the power 3 automatically it's supposed to give you 343. Okay, so that's what you are going to do to all of them. Okay, determine the exact value of each of the following without using a calculator. Now we're not using a calculator, and we're trying to determine the exact value of each of the following. Now for you to be able to solve such kind of questions, some of the basic rules of logarithmic functions is that if you've got a log of, let's say the log of 1, the log of a constant, the log of like a constant, just like that, this is like a 0. Okay, now if I've got a log of, let me say I have a base. If I haven't put a base, it just automatically get the common log. The common log, there are 2 types of logarithmic functions. There is a common log which has a base of 10, and there is the natural log. Natural log has a base of e, or what we abbreviate most as in. Okay, so that is what we're talking about. So the log of, let me say 10 and 10, because the base and the log that you're finding are the same, this is equals to 1. So when they given a log expression, try at least by all means to reach like this. Okay, and we've talked about the power. When this 10 has a power, let me say 3, you know that the power drops. Okay, we talked about that. So these are some of the rules that you're supposed to consider. So I've got a log of 7, log of 3, the base is 7. So let's start with a. We are saying log of 7 343. Now I think we had the previous question which was talking about 7 to the power 3 equals to 343. So from that concept, it even makes our work easy. So this is the same as log of, the base is 7, so we said 343 is just the same as 7 to the power 3. Okay, so now the 3 can drop. I'm going to have 3. Now the log of 7 to 7, this is just the same as 1, like we said. So what are we going to have? 3 multiplied by 1, that is a 3. So that is your answer. So that's how we're going to be solving all of them. Let's come to b. B, we are saying the log of 256. The base is 2. So we'll have to look how many times you can multiply 2 to give us 256. So what are we going to have? What number? So log of 2, I'm finding to the power 8. When I say 2 to the power 8 is giving me 256, therefore my answer is just going to be 8, because this expression is going to give me a 1. When I come to see log of 3, 3, we're saying log of 3 over 8, that is the base of 27 over 5 and then 12, 512. Now what are we going to do? You know that when you multiply 3 times, it's going to give you a 27. When I multiply, let's say 8, how many times? Or let me say, which number can I multiply? So that gives me 512. How many times am I supposed to multiply 8? I'm also supposed to multiply 3 times. So what am I going to have? Therefore, this is just the same as what I have this side. I have log of, this is 3 over 8. This is the same as 3 over 8 to the power to the power 3. Okay, then this and this are the same. They're going to just divide. This whole expression is going to give you a 1. Then you have the power as a 3. When it drops here and it multiplies with that 1, you're just going to have a 3 as an answer like that. Okay, so that's what we're going to do to all of them. Now let me also solve the one that has a point. Let's solve E as well. Yeah, because most of you will be like, sir, you didn't solve that question. Yes, let's just solve all of them, especially the ones that people mostly ask. 0.1, 0.001. Okay, so how are we going to solve that one? You know that 0.1 to the power, let's say 3, it will give you this. Okay, you're going to multiply the 0, it's going to give you 0.003. so what are we going to have? We're going to have the log of, the base is 0.1, this will be 0.1 to the power 3, because it's the same as this. Okay, so you can multiply that, you're just going to find that. And because this whole expression gives us a 1 and we have a 3, the 3 is just going to drop, so you are going to have 3 multiplied by 1, and 3 multiplied by 1, that is just a 3. So that's how you're going to solve these kinds of questions. Okay, so let's solve question number 8. Okay, use the laws of logarithms to simplify each of the following as far as possible. Okay, let's start with A and another one that has different bases. Okay, so we're saying the log of 5 plus log 12 minus log 15. Now you're able to see that all of them have got they've got the same base. Okay, so what are we going to do? Let's start with the first one. I'm going to write the same base, log of 2. Now when you're adding according to logarithmic function, when you're adding two logarithmic functions or expressions and they've got the same base, what do you do to your log that you're finding? So it means we're going to multiply 5 is going to multiply by 12. Then we've got a minus the log of 2, 15. Now when I find the log of, let me say log, the base is 2, 5 multiplied by 12, 5 multiplied by 2, that is like a 10, 5 multiplied by 1, that is 1, plus that 1, that is like a 60. So that is that, minus the log of 15. Now the base is the same, I'm going to say log 2. Okay, now because we're subtracting. When you're subtracting two logarithmic functions, what do you do to the corresponding values? So we're going to say 60 now will be dividing by 15. Therefore now what will be your answer? You're going to have the log of, let's say, which two numbers can we divide to, you know, simplify it further. So if I divide, let's say 5 into this, that is 5 into 15, that is a 3, 5 into 6, that is a 1, remainder 1, 5 into 10, that is like a 2, 3 into 3, that is a 1, 3 into 12, that is a 4. So this is a 4, and we can simplify it further. You know that this is the same as log of 4 is the same as 2 to the power 2, right? And we have a base of 2. The 2 is going to drop, and when it drops, I'm going to have 2 log 2, and there's a base of 2. Now we said when you have a base and the log are the same of what we're finding, it's just that expression is just going to give you a 1. So we have a 2, and this expression gives us a 1. 2 multiplied by a 1, that is just a 2. And that's how we're going to solve all these ones. Okay, maybe let's solve another one. Okay, let's solve another one. Okay, let's solve D. D, does it have a different base? Okay, it has a different base. Let's solve them with a different base. So it's the same principle. 4 log 8 plus 3 log 8, 16 minus 4 log 4, 3, 2. So that is our equation. So what are we going to do now? This is not very much complicated. So what are we going to do? So this 4, what if we take it back to the way it was, then we simplify. Okay, then we simplify. Okay, the bases are different, so you have to consider changing to one base, and that's how you're going to go about this question. Okay, so what can we do? Okay, before we do that, we can also cancel 3, we can also cancel 2, so we can say 4. Let me just use a different color. Let's say you're saying 4. Now this is the same as log 2. 8, I can also write it as 2 to the power 3, right? Plus 3. When I come to the other side, log of 8 over, the 16 there, this is the same as 8. 16, I can write it as what? 16. 2, is it 2? I want to try something. I want to try something. 16. Which one can we get? Okay, so I think we just convert all of them to base 2. Now when you're converting a log to a base 2, let's say this one, log of 8, 16, this is 3. Let's say you're converting to base 2, so you're going to have 3, you're going to have the log of 16. Since we're converting to base 2, you write it divided by, you're going to have the log of 8 now. This is to the base the log of 8, the base is 2. So what do you have? So you can say 3 log of, this is 16. How can you write it in terms of 2? That is 2 to the power 4. So let me just rub it there. So this is the same as 16. It's just the same as 2 to the power 4, right? And you know that 2 and 2, they are going to divide. I'm just going to remain with a 4. So on top, I've got 3 multiplied by a 4. Down, I've got what do I have down? That is log of 8. 8 is just the same as 2 to the power 3. Okay, 2 to the power 3. Then the 3 drops. I'm going to have a 3 down like that. Okay, I'm going to have a 3 down like that, and when I solve that, what do I have? The 3 and the 3, you know, can divide, and what do I have as my answer there? I think I only have like a 4 when I convert it to 2, to base 2. Okay, let me also convert the other one, the last one. So when I'm converting this -4 log, let's say log, when I'm converting to base 2, I'm going to write 32 the base, then I'm going to write the log of 4, the base is 2, the one we're converting to. So I'm going to say on top of -4, 32, which, how many times would you multiply 2 to give us 32? You know that that's 5 times. So this 32 is just the same as 5 2 to the power 5. Okay, so it's, if it's 2 to the power 5, the 2 and the 2 go, 5 will multiply by the -4 there. So this will multiply by the -4. Now this 2 multiplied by 2 they've got 4. 4 is just the same as 2 to the power 2. Okay, so this expression on top is just going to give me a 2. It's going to give me like a 2. Okay, then you do your math. What are we going to get? That is like -4 multiplied by 5, that is like -20, divided by 2, that is like -10. Okay, then on the other side we've got 4. This will give us a 1. Then I've got the power 3. 3 is going to multiply by 4. When 3 multiplies by 4, that is like a 12. So I have like a 12 plus 4 minus 10. 12 plus 4, that is like 16 minus 10. 16 minus 10, that is like what? Is it like a 6? Yeah, so that's what we're going to solve. Just know how to convert from one base to another. Okay, so that is very, very important. Now write each of the following into a single logarithm with a coefficient of 1. Okay, they want the coefficient to be 1, so these ones are very straightforward. So if we want the coefficients to be 1, we're just going to take them back to the way they were initially. Okay, so what are we going to do? So the first one, a, we're going to write natural log of t. Now the 7 has to go back to the way it was, so it's going to t to the power 7, right? Then we've got minus natural log of s. Now the 6 is going to go back, plus natural log of w. The 5 is going to go back. You are done. The coefficients of this expression is 1 throughout. For b, okay, for b, what am I going to write? I've got a log of z plus 1. What is the power? It's half. It's going to go back. Minus, I've got the log of, x. The 2 is going to go back. Minus, I've got the log of y. The 4 is log of y. The 4 is going to go back. I've got minus log of z. The 3 is going to go back. The coefficient throughout, it is a 1. When you come to the other side, then you also do the same to the to the last one. Okay, so you also do the same to the last one. So to the last one, now we're going to write it the same principle. You take everything back to the way they were. Okay, so that's how you are going to solve these expressions. Then number 10, we're taught to sketch the graph of each of the following functions. Okay, these ones are natural logs. Okay, So it was finding the graphs of natural logs. So allow me to say this is our x-axis, this is our, that's our y-axis, this is our x-axis. So if we draw it like that, y and x. Okay, so this is a natural log. Okay, the one we're solving for E was like Euler's number. Euler's number is a number, okay, like 2.7. That's why we had to solve it like just like any other exponential functions, because Euler's number is just a number and a number raised to a power. We were having like f of x. I didn't mention that, but f of x is x to the power maybe negative x. Yeah, this E, it is Euler's number. Okay, it's a number like 2.7. Now the number has been raised to a negative power, so this is an exponent. That's why we're solving it like an exponential, graph. But now, what about this scenario that we have? These are natural logs. So for a natural log, we said you have to consider the the vertical asymptote as your as a line that you're not supposed to touch. In this case, it's a y-axis. Now what are we now going to do for the first question? So not very much different. We are saying a is f of x is equals to natural log of x minus 3. So what you are going to do for you to find x minus 3 tells you something. You've shifted the x in a certain direction. Okay, to x you are subtracting 3. So what are you going to do? Get the whole expression, you equate it to 0. X minus 3 is equals to 0. Therefore x is equals to, when the 3 goes to the other side, becomes a positive. So you've shifted your vertical asymptote from 0, 0. Now you've shifted it to 3. So where is x equals to 3? So let's say x is equals to 3, it is this point. So this will be our vertical asymptote. Now what other things are you supposed now to consider? So your graph can be in this region or in that region. But for you to now determine, look at the values of x and the values of the function. The value of x in this case, you're able to see that x in this case is positive, so you're going to the positive values of x. What about y? The value of the whole function, it is also positive, so you're going to the positive values of y. Okay, so now how do you go? So it means you're going to go approaching this line, but you're never touching it. You're going to where x is positive, where y is positive, in that direction. Now you're going to cut this point. So what is that point? You know that that point, it is the x-intercept, and on the x-intercept, what is y? Y is equals to 0. So 0 is equals to natural log of x minus 3. Now natural log has a base of e. Even if they haven't given you, it has a base of e. So now how do we convert these ones to logarithmic functions? You have to convert it to logarithmic functions for you to be able to solve for x. So what are you going to do? Like we've been saying, since this is a base and you want to convert it to logs, so this will be you want to convert it to an exponent, to an exponential equation. So what are you going to do? Since this is the base of the logs, it will be the base of the exponent of the exponential equation. So e to the power 0 will be equals to x minus 3. So we're saying e to the power 0 is equals to x minus 3. So that's what that concept of converting from one base to, from logs to exponentials and vice versa is very important. So e to the power 0, that is just a 1. Any number to the power 0 is equals to 1. X minus 3, when I take the 3 to the other side, it becomes a positive. So our 3 plus 1 is equals to x, and therefore our x will just be equals to what? 3 plus 1, that is just a 4. So this point here, it is a 4. That's how we are going to solve this one. So let's solve B. So for B, not very much different. We are saying g of x is equals to 1 plus that. Okay, Allow me just to wrap this part. So what are we saying? We're saying g of x is equals to 1 plus natural log of x plus 4. So how are you going to do that? Now we have a shift in the y. The 1 is a shift in the y, and you also have a shift in the x. So you have to consider those vital things that have been given. So first find the shift in the x. Let's equate it to be this to be 0. What is in the bracket? X plus 4 is equals to 0. Therefore x is equals to negative 4. So it means that is where our asymptote is going to be. Let's say our negative 4 is here. That is our negative 4. Now our graph can be in this region or in that region. So what do? We have to look at also the shift in the y, where we're not supposed to a shift in the y direction. Does a shift really do a lot when it comes to because it just means we've moved the graph 1 unit up, okay, in the y direction. But let's find out. So what are we going to do? So let's find what can we find the x-intercept, where our graph is going to cut the x, and where our graph is going to cut the x, we know that y is equals to 0. So y or 0 is equals to 1 plus natural log of x plus 4. And when you solve that, when the 1 goes to the other side of negative 1 is equals to natural log of x plus 4. Now natural log has a base of e, okay, so the base will get this one as a power, and the negative 1 will be equals to what is in the bracket. So we have e to the power negative 1 is equals to x plus 4. Okay, now that you've got that, okay, so this is going to be a bit tricky. So we're going just to say we take the negative 4 to the other side. So I've got e to the power negative 1 minus 4 is equals to x. So this is our answer for x. So now how is it going to go? So it's going to go like this. Going to the positive values, let's see, x in this case it is positive. You're about to see that x is positive. What about the value of the whole function? The value of the whole function is also positive. So we're going to the positive values of x and the positive values of y in that direction. Okay, so we're also going to cut the x-axis, the y-axis there. Where cut the y-axis, it's going to be what? X is going to be 0. So if I put a 0 here, I have the natural log of 4. So I've got 1 plus natural log of 4. Since we don't have a calculator, natural log of 4. So you are going to use a calculator to find that point. So on my point, when 1 plus 2 point, the natural log of 4, what am I getting? I'm getting a point like negative, that is positive. It's a positive, actually it's 2 as a value of y, 2.38629. okay, then I can also find this point, the one that we found, e to the power negative e to the power negative 1 minus 4. What am I finding? I'm finding negative 3.63212. okay, so if I'm using a calculator, that's what you're going to find, and that's how you're going to solve these other ones. So we've solved much of graphings. Let's solve some equations. Okay, now equations from all the rules that we've talked about, so you also have to be able to solve equations. So let's start with the first one. So we're saying 3x squared is equals to 9 negative 2x plus 6. Okay, so when you're doing this, it's either going to be asked to find the missing power or the missing base. The missing power, it means you're finding the value of x. The missing base, it means you're just finding the base itself. So in this case they want us to find the value of x. Solve each of the following exponential equations. So it's an equation, so make sure that when you're doing that, make sure that you're making the base to be the same. Okay, so if we're going to make the base to be the same, what are we going to have? This side I'm going to have 3x squared is equals to 9. Can also be written as 3 to the power 2, right? Because it's going to give us a 9. Okay, we've made the base to be the same. There's a negative 2x plus 6. Now that the base are the same, we always assume that also the powers are the same. So what I'm going to do, I'm going to get x squared will be now equals to, now when I distribute the 2 with what is in the bracket, 2 multiplied by the negative 2 there just gives me a negative 4. So I have a negative 4x. 2 multiplied by 6 on the other side, that is like a 12. Now that I've got this, I'm going to put the like terms together, or I'm going to write it in the standard form, x squared. When I take the negative 4x to the other side, I have positive 4x. When I take the positive 12 to the other side, becomes it becomes negative 12. This is equals to 0. Okay, can the sum and the factor method work? Let's try. The product is negative 12. The sum, it is like 4. Two numbers, when we add them, they give us, a 4. But when we multiply them, they give us a negative 12. Okay, so what are those two numbers? Okay, so what are you going to do? So you know that 2 and negative 6 and 2, they are going to do that, right? So I'm just going to say x plus 6. I'm also going to say x minus 2. That is equals to a 0. Okay, yes, because positive 6 minus 2, that just gives us a 4, but when you multiply, it just gives us a negative 12. Therefore now the values of x is just to be, x will be equals to negative 6 and x will be equals to 2. These are the two answers, but you also have to try them to find out if your answer is correct. You have to test these values in these, but now these are big numbers, but these will be like the solutions. Okay, now let's solve B. Now I'm going to solve almost all of them because this is very, very important. It's very important to know how to solve equations on this topic. 1 plus x is equals to 1 over 64 4x plus a 2. Okay, now 4 I can also write it. Which base can I choose? Let me say I want to change them to the base of 2. 4 I can write it to the power 2 to the power 2, right? Then I have x 1 plus x on top is equals to 1 over 64 in terms of 2. What is 64 in terms of 2? I want to make an 8, because 8 times 8 will give me a 64. So I can say 2 to the power 3 multiplied by 2 to the power 3. Okay, so therefore I've got 2 to the power 6. So 64 is the same as 2 to the power 6. So this is 2 to the power 6. This is multiplying by 4x plus a 2. Okay, now that I've got this, what can I do? I can write this expression as 2. When I distribute the 2 on top, I'm going to have 2 plus 2x, right? Okay, on the other side, now I can, that because it's a 1, the 1 initially it was a negative, right? So I can write it 2 to the power negative. Okay, now what does it have? It has a power. 2 has a power. Let me first distribute 6 multiplied by 4x, that is like 24x. 6 multiplied by 2, that is like a 12. Okay, then I need now to distribute the negative. So I'm going to have 2 plus 2x is equals to 2 minus 24x minus a 12. So now that the bases are the same, I'm going to now equate the powers. So it's 2 plus 2x is equals to negative 24x minus 12. Now that I've got this, what do I do? We solve for x. So how are we going to do? If I take the negative 12 to the other side, I'm going to have 2 plus let's see, what do we have? Okay, let me start with x. If I've got let's say 2 plus 2x, when the negative 12x 24x, when it comes to the other side, becomes positive. 2x plus 20, that will just give us a 26x is equals to negative 12. Now that I've got this, I'm going to have 26x. When I take the 2 to the other side, negative 12 minus 2. Okay, that's what I'll have on the other side, minus 2. So therefore it's 26x is equals to negative 12 minus 2, that is just like negative 14. Therefore I'm going to divide by 26 on both sides. Therefore my x is going to be negative 14 divided by like 26. We're going to look for two numbers that are going to, let's say 2 into negative 14, that is like negative 7 over 2 into 26, that's like 13. So this will be the value of x. Okay, so we solved B. Now let's solve C. So C, we are saying 8 4x squared minus 1 is equals to 1. So what are we going to do? Okay, very simple question. 4x squared minus 1 is equals to 1 here. How can you make to have a base of 8? So we're just going to say 8 to the power 0, because any number to the power 0, it is a 1. So because of that, the bases, since the bases are the same, we're just going to get the powers. 4x squared minus 1 it is equals to 0. So what do we do? If I take the 1 to the other side, what do I have? I have 4x squared is equals to a 1. Then I can, what can I do in this case? I can divide by a 4 on both sides. Therefore x squared is equals to 1 over 4. For me to remain with x, I'm going to do the square root on both sides. So therefore x is equals to positive or minus. Now this square root drops on 1, it also drops on 4. Therefore the square root of 1 is just, so the answer is positive or minus. The square root of 1 is a 1 over the square root of 4, that is a 2. So our answer is negative half and the positive half. So let's solve D. So our D, we are saying 2 plus x is equals to 8 plus 2x. So again, we have to strive to have the same base, usually 2x. So 4 to the power 2 is just the same as 4, right? 2 to the power 2, that is the same as 4. I've got 2 plus x is equals to 8. In terms of 2, it's just the same as 2 to the power 3, right? Then I've got 8 plus 2x as the power. Then we equate the powers. So when I distribute what is on top, when I distribute the 2 on top, what do I have? 2 multiplied by 2, that is a 4, plus 2 multiplied by x, that is a 2x, is equals to, when I come to the other side, 3 is distributing with everything that is in the bracket. Now 3 multiplied by 8, that is like a 24, plus 3 multiplied by 2x, 3 multiplied by a 2x, 8, 16, okay. 3 multiplied by 2x, that is like, is it a 4? Is it a 6x? Okay, now that we've got this, what do we now do? We just put the like terms together. So 4, when the 4 goes on the other side, if I take the 4 to the other side, I'm going to have 20 on the other side. 24 minus 4, that is like a 20. This is 2x. When I take the 6 to the other side, I'm going to have a negative, is it negative 4? Is it a negative 4x? Yeah, negative 4x. So because of that, I'm now going to divide by negative 4 on both sides. Therefore my x is going to be negative 5. Okay, so that is the solution for D. Then which other one can we solve? We can also solve E. So E is 2 to the power 7x is equals to 3. Okay, so what I was writing here? Okay, so that is our E. So how do we solve, such a one? So you can introduce natural log on both sides. Okay, so is it going to do as good if we introduce natural log? Or let's say, since this is a base, so we're going to take this base as a log. Okay, so let's say log in base 2. Okay, so I can say log in base 2 7x is equals to log in base 2 is equals to 3. That's what I'm going to do. Okay, if I introduce log, actually I've made a mistake here. So if I introduce log in base 2, this is 2 to the power x, 2 to the power 7x is equals to log 2, then there is a 3. So that's how it is. Okay, so now that I had forgotten that, so what are we going to do? This power is going to drop. I'm going to have 7x. This expression gives us a 1 according to what we've been solving. I've got a log of 3 in base 2. Then what do I have? For me to remain with x, I'm going to divide by 7 on both sides. Okay, therefore our x will just be equals to the log 3 base of 2 over 7. So that's how you're going to solve this one. Okay, what are we now going to solve? Let's solve some other questions. Let's say we want to solve f. I'm going to try to solve a lot as I can from this part, because you just have to know how to solve equations. They are not very difficult, they are as simple as, so if I take this one negative, the one that has a negative to the other side, okay, I'm going to have 9 is equals to e to the power 6, e to the power 6x. Now if I introduce the natural log on both sides, what am I going to have? So I'm going to have natural log of 9 is equals to natural log of e to the power 6x. Okay, so what are we going to have? You know that your natural log has a base of e, so it means this expression is also going to give us a 1. Okay, then we have a 6x, so we have a natural log of 9 is equals to 6x multiplied by 1, which is the same as 6x. Okay, so I'm just going to write it, just to leave it as 6x. For me to remain with x, I'm going to divide by 6 on both sides. Therefore my x is equals to natural log of 9 over 6. So that's how we solve, that. Okay, let's solve g. We are saying 7x squared minus 2 is equals to 49. So it's the same thing, you make the base to be the same. So 7x squared minus 2 is equals to, there's 49 on the other side. This is the square of 7, so this is just 7 to the power 2. It will give you 49. Now what do you do? Because the base is the same, you're just going to equate the powers. X squared minus 2 is equals to a 2. Okay, now what do? I can say x squared is equals to, when the 2 goes to the other side, it's going to add with the other 2, which will just give me a 4 on the other side. For me to remain with my x, I'm going to square root on both sides. Therefore x will be equals to positive or minus 2. positive or minus 2. So that's how we're going to solve that. Let's solve another one. So now we're solving which one are we solving? H. So h we have e to the power 2x plus 3 is equals to 7. So what are we going to do? Again, we're going to introduce natural log on both sides. So natural log of e to the power 2x plus 3 is equals to natural log of 7. Now you know that natural log is in base e. Because the base is the same, I'm going to drop the power. 2x plus 3 is equals to natural log of 7. Okay, now for us to remain with our x, I'm going to have said 2x is equals to natural log of 7. The 3 is going to come to the other side, becomes negative. Okay, then I'm going to divide by 2 on both sides. Therefore x is equals to natural log of 7 minus 3 over 2. So that's how we solve our h. Okay, which other one should we solve, or the one that we haven't yet solved? I was saying e to the power 2x minus 8 e to the power x plus a 12 is equals to 0, like that. So what do you do for this expression? Okay, we're saying e to the power that. So it's like a quadratic. So you can find two numbers that you can multiply to give you 12, but when you add them, they'll give you like some 8 there. Okay, so that's it. So 4 and 3 can do that. So I'm going to say e what can I do? Because you have to replace and make it into a quadratic expression. Okay, let's just replace. Let's not feel lazy. Let's replace. Let me write it nicely. We're saying this is e to the power 2x minus 8 e to the power x plus a 12 is equals to a 0. So we can choose any letter. Let's say we were choosing u. We say u, let's say we let u is equals to, let's say, e to the power x. Okay, so you know that this is e. I can separate it as, I can write it like this, x. I can put the 2 outside. For the first expression is equals to 8 e to the power x plus a 12 is equals to 0. Then I replace u wherever there is e to the power x. Now when I replace u, I'm going to have u squared minus 8u plus a 12. Okay, this becomes a quadratic expression. Okay, so let's solve the quadratic. So if that is our equation, what are we going to do? So therefore u will be equals to negative b positive or minus the square root of b squared minus 4ac over 2a. So negative b, what do we have? Okay, let me say our b, we're able to see that it's 8, right? So 8 is negative 8. Because it's negative 8, this will be positive 8. Positive or minus the square root of b squared. Our b is still 8. Negative 8 squared, that is like 64. Minus 4. What is our a? Our a is what is our a? Our a is 1. 1 multiplied by 12, that is like a 12. 12 multiplied by like a 4, that is like 48. Okay, so let me just write the 48. This is 48 over 2 multiplied by 8. Our a is 1, so that is just a 2. Okay, now that we've got that, I've got 8 positive or minus 64 minus 16. Okay, what do I have? I have like a 16, or everything over 2. Okay, now the square root of a 16, that is like a 4. Therefore, I've got 8 positive or minus the square root of a 16. We're saying it's a 4 over 2. So our two answers for u will be 8 plus 4 over 2, or u will also be 8 minus 4 over 2. So the first value, 8 plus 4, that is like a 12. 12 divided by 2, that is like a 6. On the other side, 8 minus 4, that is like a 4. A 4 divided by negative 2, that is like a negative 4 divided by a 4 divided by 2, that is like a 4. Is it? What am I saying? 8 minus 4, that is like a 4. Then a 4 divided by 2, that is a 2. So these are the two answers that we have for u. Now we had to replace. We said u is equals to e to the power x. Okay, so we just have to replace. U found, the first one found to be 6, so I'm going to write 6 is equals to e to the power x. The other one we're going to say 2 is equals to e to the power x. So how are we going to find now the value of x itself? We're going to introduce natural log on both sides. So I'm going to say natural log of 6 is equals to natural log of e to the power x. And you know, for me, what am I going to have? This gives me a 1, so therefore x is just equals to natural log of 6. Then on the other side, it's the same thing. I'm going to introduce natural log on both sides. Natural log of 2 is equals to natural log of e to the power x. Therefore x is just equals to natural log of 2. So these are the two answers that we have for our cells. Okay, we've solved a lot of questions. Not bad for us. We've solved a lot of questions. Maybe let's solve the last one. Let's say we can also solve maybe k. K, we are saying it is what is it? K, we are saying it is e to the power 4x minus 3 e to the power 2x plus a 2 is equals to 0. Okay, so what do we do? Okay, it's the same quadratic thing that we did. Okay, so not really. Should we also solve this one? Okay, we solved a lot of quadratics. Not that much fine. So let's proceed. We solve each of the following log equations. So now we're solving logarithmic equations. So not much different from the previous ones. Not very much different. Okay, so what do we do? The first one is log of that is equals to this. Ooh, how can I do this? I want, okay, allow me to just copy this and paste it on the other side. Okay, let me just reduce it. Hope you'll be able to see. I want to be able to see my questions clearly. Okay, so solve each of the following log equations. So what do we have? We've got a, our a, which is log, you know, the base is 11, then I've got x squared plus 3x is equals to log, the base is 11, 3x plus 16. So this is our question. So since the logs are equal on both sides, the base is the same, so I'm just also going to just equate what we have. So we are going to have x squared plus 3x is equals to 3x plus 16. So now what do we have? We have x squared is equals to 3x. When I take the 3x to the other side, becomes negative, and there's also a 3x here. 3x minus 3x will give us a 0. Therefore on the other side I'm just going to have a 16. So I'm going to find the square root of x on both sides. X will be equals to the positive or minus 4, right? The square root of 16 is that. So those are the two answers that we have now. But for logs you have to be very careful, because you need to check your solutions whether they are going to give you that. So if I place a 4 here and a 4 there, am I going to get the other side? Okay, and if I put a negative and a negative, am I going to get that? Let's try the proof. We are saying the first one, it is, let's try for 4 just as a positive number. We're going to have 4 squared plus 3, that is multiplying by 4 is equals to 3 multiplied by 4 plus 16. 4 squared, that is like a 16 plus 12 on the, this is like a 12 plus 16. So you're able to see that this just gives us the same answer. Now if I put a negative where there was 4, it will still be the same thing, right? Because we're adding up. Let me just write it this. The square root of 4 is the negative 4, it should be a 4. So this is, both solutions are valid. Both solutions are valid. Now we come to we can also solve B. We can also solve B. Now for B, we have natural log of 4 minus 3x minus natural log of 7x is equals to natural log of 11. Okay, so again, since the powers are like the same, what are we going to do? The first ones, there's a subtraction there. When you're subtracting two logarithmic functions, what do? You add them. You are dividing them. So this is natural log of 4 minus 3x over 7x. You are dividing them, is equals to natural log of 11. Now because we've got natural log on both sides, we are just going to equate what we have. So we are going to have 4 minus 3x over 7x is equals to an 11, like that. Then we solve. Okay, we can cross multiply. If we cross multiply, what are we going to have? I'm going to have 4 minus 3x is equals to 7x minus multiplied by 11, that is 77x. Okay, now what do I do for me to remain with x? I can say 4 is equals to 77x. 77x, that is plus 3x when it goes on the other side. So 4 is equals to 77x plus 3x, that is like 80x. Okay, then for me to remain with my like x, I'm going to divide by 80 on both sides. Therefore our x is just going to be 4 into 4, that is 1. 4 into 8, that is like a 20. So our x is going to be like a 20. Okay, so that is our answer. So if you want, you can also verify that where there is x, you're putting 1 over 20. Okay, so that is how we are going to solve this one. Okay, just to verify, because people want to verify, natural log of, we are saying 4 minus 3, x we found to be 1 over 20, minus natural log of 7, this is multiplying by x we found to be 1 over 20, okay, is equals to natural log of 11. Okay, so what do we do? What do we do? 3 is multiplying on the other side, so I'm going to have natural log of, this is 4 minus 3 multiplied by 3, that multiplied by 1, that is like a 20. Okay, we've got this expression. On the other side, we have a natural log of 7 over 20 is equals to natural log of 11. Okay, so now how are we going to solve this one? Allow me to solve what is on the bracket on the other side. This one, we have a common denominator of a 20. Don't forget your natural log. Let me say it's a 1 here. 1 multiplied 1 into 20, that is a 20. 20 multiplied by 4, that is like 80. Minus 20, so I have a 3 there. Okay, minus natural log of 7 over 20 is equals to natural log of 11. Natural log of 80 minus 3, that is 77 over 20, minus natural log of 7 over 20, is it equals to 11, natural log of 11. Are these ones the same? Let's see if we're going to get. So because the log is the same, let me get this part. If we see, it's going to give you as the right hand side. The log is the same, so I'm going to write natural log, okay, of, now I've got a 77 20 minus the natural log of 7 over 20. Okay, because we've got the common denominator as 20, I can just write it as 20 like that. Then what do we have? 77 minus 7. What do we have? What can we have? Is it, what are we going to have? If I say 20 into 20 multiply, that's 1 multiplied by 7, that is a 77, minus 20 to 20, that is a 1 multiplied by 7 on top, that is like a 7. 77 minus 7, that is like a 70 over like a 20. Is that it? Okay, have we done the correct thing? No, we haven't done the correct thing. So I've done them direct, which is very wrong. For logarithmic functions, you're not supposed to do them direct, because here there's a negative. It means the two expressions are what they are dividing. Okay, this is why I missed it. So you have 77 over 20 divided by 7 over 20. Okay, that's the expression that we have. And from that, what are you going to have? You know that if you have 77 over 20 divided by 7 over 20, you know that you are going to have 77 over 20 times, the 20 is going to go up, the 7 is going to come down. The 20 and the 20 can divide, and what you're going to have is a 7 into 7 is 1, 7 into 77, that is 11. That's why you have a natural log of 11 is equals to natural log. Okay, so the solution is correct. The solution is correct. Okay, so let's solve D. So D, we're saying the log of, are we solving D or D? Okay, D, log of, we've got 8 log of 8, where is it? Log of 8, that is 4x plus 1 is equals to negative 1. Okay, so that is our question. So what are we going to do? Okay, okay, we have a log of 8 is equals to 4 plus okay, so I can write which one. Okay, so in terms, solve each of the following equations. So for me to solve this one, I think for me I'm going to convert it to, because this is giving us this, I'm going to convert it to an exponential function, okay, to make my work as simple as possible. Okay, and you know that when you're converting that to be a to the power negative 8 to the power that, and this is equals to that, so to be a to the power negative 1 is equals to 4x plus 1. So that is if you convert it like that. Okay, then what do we have? I can now find the value of x. So for me to remain with my x on the other side, I'm going to have x to the power negative 1. When I take the 1 to the other side, it will be negative 1 is equals to 4x. Okay, then 8 to the power negative 1, that is just the same as 1 over 8 minus 1, okay, is equals to 4x. So what am I going to have? 1 over 8 minus 1. If I'm going to solve this, that is 1 minus, that is like 8, that is like 8, that is like negative 7 over 8. So I have negative 7 over 8 is equals to 4x. For me to cancel the 4, I'm going to divide by 1 over 4 on both sides. 1 over 4 on both sides. So this and this will go. My x therefore be equals to negative 7 over 4 multiplied by 8, that is like a 32. So therefore x will be negative 7 over 32. So that's how you are going to solve, you know, all these questions. Not very hard, and they are just as simple as that. Now let's solve the last question. We are saying a population of bacteria initially has 90,000 present, and in 2 weeks there will be 200,000 bacteria present. Determine the exponential growth equation for this population. So this is the application of logs. How do you apply them now in real life situations? Okay, so let's solve the first question. Now for us to determine the exponential growth equation for the population, there's a formula that you're supposed to use. So it is pt is equals to p initial multiplied by the exponential rate times time. So you have to know this equation. For you can't solve this equation without you know this formula. So now the pt in this case, it is the population at a time t. Then the p initial, this is the initial population. Then we have r. The r in this case is the growth rate. Okay, then the t is the time. So this is our equation. So the p initial been given, initially the population was 90,000. The p final, what is the p final? We've been given the p final as 200,000. Okay, so if we've been given that, so what do we now do? For us to find the exponential growth rate, we want to find the r, which is the exponential growth rate. So we just have to substitute in the equation. Okay, so the pt, we're saying this is the population at a certain time, which was at 2 weeks. Okay, which was at 2 weeks. So that population was 200,000 is equals to the initial one, we had 90,000. Okay, multiplied by our e, then the time, you're able to see that we're talking about 2 weeks here, so it's 2 multiplied by r. Okay, now what do? We can divide by 90,000 on both sides. So we have e to the power 2r. Now I can cancel the zeros. These three zeros will go 1 0 and 1 0. I've got 20 over 9. This is 20 over 9. For me now to find the value of r, I can introduce natural log on both sides, right? If I introduce natural log here and natural log there, what do I have? So you know that this other side I'm just going to have 2r divided by the natural log of 20 over 9. Okay, natural log of 20 over 9, like that. So now for me to find the value of r, therefore I'm just going to divide by 2 on both sides. Therefore r will be natural log of 20 over 9 divided by 2. So this will be your answer, and that is the value of r. Okay, so determine the exponential graph equation. Now they want the exponential growth equation. They want an equation. So what would be the equation? So our equation will just be the whole equation, but where there is r, we're just replacing the one that we found here. So we're going to say pt, okay, will be equals to 90,000 multiplied by e, the value of r that we found, natural log of 20 over 9 divided by 2, this, and multiplied by t. This is an equation. Okay, so that's what they want for the first question. Then b, how long would it take for the population to grow from its initial population? Okay, we found r as that. Let me just keep our r this side. We said r is equals to natural log of 20 over 9 divided by 2. I can rub now everything. So b, we are told to how long will it take for the population to grow from its initial population of 90,000 to a population of 150,000. Okay, this is very nice. So for us to find how long it will take now for the population to grow from that point to that point, we just have to get our pt, okay, to be equals to 150, because that's how much it has, you know, increased. And we have to now solve for the time, because we're trying to find how long. So what are we going to have? So you know, in our equation we're going to have 150, you know, 1000 as our pt is equals to your p initial. Your p initial is 90,000, the one that we started with, multiplied by the exponential. Now we've already found r to be natural log of 20 over 9 divided by 2. Then we're finding time. Okay, so I can divide by 90 on both sides. 90,000. Okay, so when I divide on 90 on both sides, let me cancel the zeros on the other side. I've got 15 divided by 9. 5 into, let's say, okay, 3 into 15, it can go like 5 times. 3 into 9, that is like a 3, is equals to e to the power natural log of 20 over 9 divided by 2, then there is a t there. Now that we've got that, I can take the natural log on both sides like we did in the previous one. So if I put natural log here and natural log there, you know that this one just gives me a 1. Therefore, what do I have? I'm going to have a natural log of 5. Okay, allow me just to rub this side. I'm going to have natural log of 5 over 3 is equals to this other whole expression that we have, natural log of 20 over 9. This whole expression is divided by 2. Then we've got a t outside. Okay, so what do we do for us now to find the other part? It means we're just going to divide by what we have. or what do I do first? Let me first cancel the 2. I don't want this 2, so I can multiply by 2 over 1 on both sides, even this side 2 over 1, so that this 2 and this 2 divide. Therefore I'm going to have natural log of 20 over 9. Then there's t this side. This side, when the 2 multiplies with that, I'm going to have 2 natural log of 5 over 3. Now that I've got this, I can now divide by natural log on both sides. So this is natural log of 20 over 9. Even this other side, natural log of 20 over 9. Okay, so this can cancel. Therefore our t is equals to 2 over natural log of 5 over 3 divided by natural log of 20 over 9. Now using the calculator, I'm finding so I'm finding 1.39. that is the time. Now this time you're able to see that we're given in weeks, so even this time will be in weeks. So the time is 1.39 weeks approximately. So it would take approximately 1.39 weeks for the population to grow from that 90,000 to about 150,000. So this is how you solve questions in this tutorial sheet. So thank you for your attention and your patience. Don't forget to subscribe to our channel and follow us through like that.